All right, guys. So this one's going to be a little longer, I think, than the previous weeks, and that's because we're going to get into something that I'd say is pretty complicated, even if you understand this stuff. But it's kind of necessary for where we're going to go. If we're going to talk about bundle branch blocks or blocks that occur at the AV node, right, the part of the heart that holds that signal so the ventricles can fill. So we're going to have to understand the stuff we talked about in this video today, and it's a little more dry. It's not like super applicable right away. You're not going to finish this and then be able to run off and recognize 4 more things on a 12 lead, but super foundational for kind of taking the next step. And so again, like quick recap, right? We just talked about what the P, QRS, and T waves are, what they actually represent, what's going on in the heart. Talked about how to recognize an MI through ST elevation. Talked about atrial fibrillation and what that's going to look like, and then talked about VFib and VTAC in CPR, and then why we defibrillate those patients, why we shock them. So today we're going to talk about the 12 lead, why there's different leads. So if you can see, up here in the top left corner, we have lead 1, lead 2, lead 3. And I'll get this out of the way right now. This all down here you can just ignore. So the 12 leads we get in the field aren't going to have this lead 2 right here, which is the same as this lead 2. It just runs all the way across the paper, so you can get like a longer strip, which when we're talking about problems in the AV node is really useful to have a long strip of one lead, which with the 12 lead you don't get, right? You just get these little, like in V2 here, you just get this little segment, and sometimes that's an issue. So we can just go ahead and ignore the bottom piece here, because a normal 12 lead is going to be the stuff that's circled in green here, right? It's going to be this stuff. This is what we'll print out in the field. So cool. With that, real quick, let's talk about the difference between 4 lead and 12 lead. So a 4 lead is gonna be with 4 stickers, right? So if you're used to putting these on, they're called the limb leads. And there's different spots they can go, but traditionally, if you go by the book, then the left arm goes on the left wrist, right arm on the right wrist, and then your 2 leg leads will go on the inside part of the lower calf. And that's going to give us the views of 1, 2, 3, AVR, AVL, and AVF. And so right away, you're like, well, what? 4 lead, why do we get 6 views? And yes, and we don't have to get into why that's the case. To be honest, I think it's way above what we need to know. But suffice it to say, a 4 lead can give us 6 views. But also, the 4 lead isn't as sensitive as the 12 lead is. And what I mean by sensitive is you could see ST elevation in lead 2 on a 4 lead, and it looks really big, that guy's having a heart attack. And then you put a 12 lead on, and that ST elevation goes away. And so the 12 lead is a much more diagnostic tool. So I'm never going to put someone on a 4 lead and say that they're having a heart attack. A 4 lead's really, really good for giving us to figure out what rhythm they're in. So for example, if they're in AFib, a long strip that's maybe 10 seconds long of just lead 2, which kind of like the one that we have down here at the bottom of the page, right? That's what a 4 lead can give us. So super useful, and you should always print one out because you always hook up a 4 lead first before you hook up a 12. So if you've ever put a 12 lead on, the stickers that are V1 through V6 are actually on a separate strand. It's like that you have to click into the 4 lead box. If you don't know what I'm talking about, don't worry about it. But you're always going to put a 4 lead on before you put a 12 lead on. So you might as well print out a strip. And the lead that we've been talking about this whole time, even though we haven't really mentioned it, the lead that we are paying attention to and that we teach 4 and 12 lead off of is lead 2. And we're going to talk about why that is. But just for now, say, okay, lead 2 is the one that I know how to read. And you're going to see that it's really the same rules for all of them. There isn't really too much of a difference. So why do we have all these different leads, right? Why have these 12 different views? I mean, what are they really saying? Because if you just take a quick glance over all of this, I mean, it pretty much looks the same, right? I mean, if you look in lead 2, you can see a P wave right here. Oh, let me get the red, because that's way too thick. So you get a P wave right here, you have a QRS, and then you have a T wave, right? Well, if we go all the way over to V5, it's the same story, right? P wave, QRS, and a T wave. So what am I gaining by having all these different leads? And really what they are is they're different cameras that look at a different part of the heart. So we're going to start that off by just saying we're going to group these leads together by which part of the heart they look at. So pretty simple. Imagine we're all standing around a car, right, in a big circle. Well, some of us are going to see the rear bumper and the trunk, and other of us are going to be standing in front of the hood and the windshield, and we're going to see different parts of the car. And so if someone threw a rock at the car and hit the front bumper, well, the people standing in the front of the car are going to see the damage to that front bumper, but the people on the back of the car are just going to see a totally normal looking car, right? And that's exactly what's happening with our 12 lead. Our 12 lead looks at different parts of the heart, and if there's damage or like a heart attack, right, if there's a blockage in a certain part of our heart, the leads that look at that part of the heart are going to show that there's an issue, okay? So let's break down real quick what looks where. And again, this is stuff that if you ever went to medical school, you need to have down, because when we call the doc, and I'll explain it later, we need to tell them what part of the heart is having an issue. We need to build the case that these people are having a heart attack in a certain area. But for now, I want to kind of demystify why there's all these different numbers. So first off, we will take 1 AVL, V5, and V6. Now, all of these look at the lateral part of the heart. So again, if I had ST elevation in V5 and V6, then it would be telling me that the lateral part of the heart is having a heart attack. Same if 1 in AVL had ST elevation. I'd be saying there's a heart attack in the lateral part of the heart. So those all look at the same part of the heart. Leads 2, 3, and AVF, they look at the inferior part of the heart, or the bottom of the heart. And what's really unique about 2, 3, and AVF is they look at the right ventricle. All the rest of these leads pretty much look at the arteries surrounding the left ventricle. So the inferior looks at the right ventricle. And this is the only reason why EMTs aren't given nitro. So if we were to have ST elevation in leads 2, 3, and AVF, then it's pretty certain that the heart attack is happening on the right ventricle. And the issue with nitro is, because it's a vasodilator, is that you'd actually make the situation worse by giving someone who's having a inferior MI, an MI in leads 2, 3, or AVF. You could actually make them worse by giving them nitro. And as an EMT, you don't have a 12 lead, right? And so the symptoms are going to be the same, signs will be the same, but you don't know where in their heart they're having that issue. So if you were to give them nitro and they're having an inferior MI, you can make it worse. And then that's it. That's the reason why EMTs don't carry nitro. They can only give it if the doctor's prescribed it. And the doctors prescribe nitro most likely because inferior MI is not the concern for this patient. It's still possible that they're having an inferior MI, so you need to keep that in mind. If you give someone their own nitro and they get way, way worse, then the chances are they're having an inferior MI this time. And it's going to be really important that you tell the medics that when you show up and say, hey, here's the story, here's a set of vitals, here's what we did because of that, but he has gotten so much worse since we gave him the nitro. That's going to key me in to say, he's probably having an inferior MI. And we'll throw the 12 lead on and we'll try to diagnose that. So inferior MI, leads 2, 3, and AVF, a little bit different than the rest of them, and those look at the inferior part of the heart. So let's switch colors here real quick. So the parts remaining are V1 and V2. So they're the septal leads, and they look at the septum of the heart. And then grab one more color here, do the rainbow. V3 and V4 look at the anterior part of the heart, right? So anterior, just like back from EMT school, right at the front. And so the rule is to call an MI to say that someone's having a heart attack just based on the 12 lead. We need to have ST elevation in 2 leads that look at the same part of the heart. So for example, if leads 1 and AVL both showed ST elevation, then we could say we're having a lateral MI. If leads 3 and AVF had ST elevation, we could say we're having an inferior MI. The tricky part gets when you have ST elevation in V2, for example, and V3, or you could have ST elevation in V4 and V5. Well, they don't look at the same parts of the heart, right? And so you could have ST elevation in V2, but none in V1. And you could have ST elevation in V3, but none in V4. And we can't call a code STEMI, right? So that activates the cath lab at the hospital. We can't say that that person's having a heart attack for sure, but they definitely have some major issues going on in their heart. And the chances are that down the road, as we take 12 leads all the way to the hospital, either V1 or V4 will start showing ST elevation as that blockage gets worse and worse. So you never just do one 12 lead. You're going to do multiple 12 leads. It's no different than as a good EMT, you're constantly rechecking vitals, right? So when you're sick patients every 5 minutes, right? This is the same deal. We're going to take 12 leads as needed, and the machine's really smart too. If it notices a big change, it'll actually spit out a 12 lead at us. So if we ever look up and the machine's printing something out, it may have noticed something before we did. So yeah, that's the basic pattern as far as what's looking where, right? Again, 1 AVL, V5, and V6 look laterally. 2, 3, and AVF look inferiorly and mainly at the right ventricle. V1, V2 are the septal leads, and V3 and V4 are our anterior leads. So we're going to erase this. I think that's pretty straightforward. It's not super confusing. And that's why we have all those different views. So again, like if we're standing around the car and there's damage on certain sides, we can see it. If we were all standing at the back of the car looking at the rear bumper and it had front end damage, then we'd be missing it. So, all right. So a question that I get a lot is when people are very first starting to look at this stuff, they go, well, does it matter if things are upright, right? So like for right here, right, we can see, well, let's get rid of the, we don't want the rainbow. We'll do green again. You notice that the QRS complex is upright, right? It's not pointing down. So in AVR, it points down, right? So this is the most complicated, I think, piece of being able to read a 12 lead. This is the hardest part. And if you can understand this, then good on you. I mean, it took me quite a while to get this, but we'll scroll down here and we'll see if we can. We'll give it a shot. So the leads themselves, those stickers that you're placing on the patient, have both a negative and a positive. Okay. So if you have the camera, so if we have lead 2, right, and we've got the sticker on the person, it's looking, so if the person's right here, I know, super, super nice, right? Lead 2 is a camera that's looking in this direction, okay? And the heart, if you notice there, it crosses right across the heart. And if you remember the heart that we've been drawing this whole time, right, then you'll notice the electrical activity, right, that we've been talking about goes like this. It goes from the SA to the AV, down the bundle branches, and through the rest of the electrical system. Well, the camera conveniently looks right like this. So it pretty much looks in the direction of travel that the electricity is going, right? So we'll get rid of all this. And like I said, those stickers have a positive and a negative to them. So in the case of lead 2, right here, it's looking this way, right? The negative bit of the sticker is up here on the shoulder, and the positive bit of it is down on your leg. And so when the SA node, right, when the SA node sends its signal to the AV, the electricity is moving toward the positive down here. Okay? When the electricity moves towards the positive, what we see on the paper is a positive bump. Okay? If the electricity was moving away from the positive, then instead of the P wave being upright, the P wave would look negative. So it's kind of complicated, and sometimes you have to go over it a few times to really understand that. But it becomes really important when we scroll back up here, and if we look at lead 2, we notice that everything in lead 2 is upright, and that's normal because the electricity is following the normal pathway, right? So take a look at AVR. You see how our P wave is upside down, or I'm going to say negative. Our QRS is negative, and there would be a T wave right here if it didn't get cut off. That's also negative, and that's normal in AVR. And so, with a grain of salt, everything should be positive other than AVR. And there is a certain issue that'll happen where you'll have a bunch of things that are negative and then AVR is positive, and that's a huge problem. So those people are usually going to die pretty quickly. So that's kind of camera angle 101. It's not the easiest concept to get, but if you want to get really basic, then let's just say we want pretty much everything other than AVR to be positive. And if it's not positive, then there's a problem with the electrical system. The electricity is not following the path that we've been talking about this whole time. It's not going SA, AV down the ventricular electrical pathway. And when we get to talking about heart blocks, and when we get to talk about bundle branch blocks, and kind of the more obscure stuff, you're going to notice that the P waves all of a sudden start becoming negative. They start becoming upside down, or the QRSs will get really, really wide and sometimes negative. So again, down the road we'll talk about it, but that's kind of camera angle 101, right? So let's talk about, we can zoom in real close here, okay? We've got these boxes, right? And you can notice that there's big boxes and small boxes. And when we go up in the boxes, we're talking in terms of millimeters. So we're talking about terms of height, right? So if we're going to let's take this QRS complex right here, and let's count how many millimeters tall it is, okay? So we'll start here. So 1, 2, 3, 4, and we know that there's 5 small boxes inside one big one. So 5, 9, 14, and then we'll say 17. So this QRS complex is 17 millimeters tall. Okay, and we don't care how tall the QRS is really. That's not important. But I wanted to show you how you count, right? And you always count from the baseline, right? The point of no electrical activity to wherever you want to count to. So we said, we're going to count to the top of the QRS. What's really important is when we're talking, so right here would be kind of our ST segment, right? So when the ST segment is, oh my gosh, what happened? When the ST segment is elevated, so we'll see if we can just kind of fake it here. It comes down, and then we have a big T wave. What we would do is we would count from the baseline up to where the ST segment is, and however many millimeters that is, that's how many millimeters of ST elevation we have. And so when we call into the doctor, I would say that, hey doc, I've got a male patient who's complaining of chest pain, and I apologize if you can hear the guy outside with the weed whacker. As you go up and you count, let's say that's 8 millimeters of ST elevation, I would tell the doc, I'm having a patient with an inferior MI, and he's showing 8 millimeters of ST elevation. And so the more millimeters of ST elevation we have, the bigger that person's heart attack is. And you can have 1 millimeter of ST elevation, or you can have 10. It depends on how bad the problem is. Okay, so when we go up, like we were talking about right here, when we go up with those boxes, we're talking in terms of millimeters, in terms of height. Okay. When we go from left to right, when we're going this way, we're talking in terms of time. So those boxes are no longer millimeters. They're worth, each one of the small boxes is worth 0.04 milliseconds of time. And so let's go back to week 1 here. Remember I told you that the SA node is going to say beat, and so we're going to get a P wave, right? And then we said there's a little dead space right here, and that's the AV node holding the signal. And you can actually count the amount of time that the AV node is holding the signal if you count how many boxes it is between here and here. And so in this case, the AV node is holding it for roughly, we'll go ahead and say 2 or 3 small boxes. So, 0.08 to 0.12 milliseconds. And when the AV node has a problem, this gap right here is actually going to grow and get longer in time. And so we can actually count how long it's taking for the AV node to hold that signal. And there's a healthy amount of time for it to hold it. Once it gets beyond a certain amount of time, then the AV node's not working properly. And so we can count in time across from left to right. Okay? So all the big boxes, right, are 0.20 milliseconds. So you can count them by small boxes or big boxes. All right? So that's a lot, right? I mean, we talked about a lot. Where the camera angles look, right? We talked about positive and negative. Talked about what a 4 lead versus a 12 lead will do, how the 12 lead is more sensitive, right? So we're going to look for heart attacks with the 12 lead. We talked about whether things should be positive or negative and why they are, right? They're positive because of the way the cameras are looking. The electricity is going toward the camera. And then we talked about, what we just talked about was when we look up on the 12 lead, when we go top to bottom or bottom to top, we're talking in terms of millimeters and height. And then when we look from left to right, we're talking about time. The stuff we just talked about, that is the most complicated stuff in 12 lead. Hands down. If you're sitting here going, oh shit, like that was, what? Don't worry, that's the reaction that like most people have. And this is what takes time to really understand. But once you understand it, all the rest of it just flows. All the rest of it just comes. But it is kind of tricky to understand why things are negative and why things are positive. And it all has to do, getting back to that car analogy, of where are you standing in relation to the car, right? Same deal if you're looking in a mirror. If you raise your right hand in the mirror, or you hold up a piece of paper with words, it looks backwards, right? So it all depends on your perspective, and that's all that these leads are. 2, 3, and AVF are just perspectives. They're looking at a different part of the heart than V1 and V2. So like I said, this video is going to be a little bit longer. If this was too much, like, don't worry about it. This is definitely medic level stuff. If you want to be able to recognize an MI, then just go watch the MI video from week 2. That's honestly, truthfully, what, like, most nurses have to take this like same EKG course, and they're taught all this stuff, but they don't remember it. Really, what they remember is ST elevation, and for the most part, that's what matters for most people. If you're going to be a good paramedic, you need to understand all of this and be able to do it, because there's a lot of things you can find. But at a very basic level, ST elevation is going to give you, if they have ST elevation, it's almost always the case that they're having a heart attack. So yeah, hopefully this wasn't like way too much, but if it was, don't worry about it. The next video is going to get back into stuff that is relatively simple to understand, stuff that you can kind of take with you. So excellent. If you got any questions, post below. We're always here to answer and to help out, and yeah, keep growing, keep getting better.